Morning, Jensen.
Morning, how are you?
Giving a few minutes for people to come in. Okay, we're at five after. How's everyone doing?
Not too
Hey,
bad.
doing well.
Looks like I can't hear you, so let me check my sound settings. All right, try again. All right, sorry, one, I can't hear you. Let me check my sound.
Can you hear us now?
There we are. Hey,
Okay.
Hey, good morning.
hey, good morning. So, small crowd today. I think a lot of people heading to Christmas holidays at this point.
Yeah, I am mentally, but physically I'm at work.
Few more days. Yeah. It was my first time as co-lead running the meeting, so bear with me here. But how familiar are you guys with the white paper we've done so far?
I am not familiar, so this may be my first time joining. I'm
Okay.
just, yeah, so I'm not very familiar.
Okay.
I'm in a similar boat.
Okay.
Okay. Sounds good then. How'd you guys get interested in this project?
Go ahead.
Well,
Yeah.
I'm the field applications engineer for Infinol liquid cooling. And so just looking for opportunities to help out with liquid cooling and places that we could contribute as a company. So been checking out a lot of different work groups and work streams, seeing where we could find opportunities to contribute.
Mhm. Yeah.
Okay.
So I'm a research scientist for Argonne. We have dielectric fluids and getting into the immersion cooling space. So just like Jensen said, just looking at ways to get involved. We have some other team members that are involved on other in other groups, and just trying to plug in, learn what we
Perfect.
can. Mhm.
Okay. So the goal of this one is looking at what the end of life options are, how to get the total life cycle, carbon down for single phase and two phase. If you have expertise or more interest in one versus the other.
Yeah, I'm interested in the single phase. I mean, not that I'm not interested in the uh, two phase, but I have more knowledge on the single phase. And
Me
so,
too.
is this? I'm sorry. Is this looking at the like the life cycle analysis of assessment of the fluids, or just um, like calculating the carbon footprint and everything, a methodology?
Yeah, so that would be our next step. What we've done so far is a lot of the end of life options, whether that's incinerate, recycle, when to top off. So things you got to handle end of life typically.
Okay.
So we're looking at how do you get the lowest carbon. Um,
Hmm.
could use some help doing some calculations for different recycling methods.
Okay.
Yeah.
Yeah. So I have experience doing life cycle assessments. We have two refineries, Argonne does, and so I've conducted two LCAs for both refineries. So I do have some knowledge on models and things like that.
That is very good to hear. Excellent. Okay. So if you're doing the refinery life cycle, that I guess where's the start and end of that analysis?
Well, we do a cradle to gate. So we start with extraction and transportation to the refinery, which is secondary data, because we don't actually do the extraction part. We use secondary data, and then once it reaches the refinery, we have primary data that we can use for that. And then we can calculate the transportation to our terminals and to customers, but we don't do end of life, or we don't do use phase and end of life, because our products go into so many different applications that it would be impossible for us to do that. Um, yeah, so
Certainly.
we don't have end of life either.
Okay.
Mhm.
So Yeah, we're looking at the similar concept, but more for the end of life. So gate to grave.
Okay.
Yeah, probably exclude how it gets there, but
Yeah.
yeah, a lot of people are asking in the immersion space what to do with that at the end.
Okay.
I'd say a pretty common way is there is standard oil recycling like you do with a motor oil, but might not be the most efficient. So trying to figure out what the optimal outcome would be. Probably
Hmm.
matters where it's located.
Right.
Yeah. Okay. Or do you help then? And Jensen, are you interested in single phase, two phase, everything? What's your experience?
My experience is more. I've done a little with two phase on a thermal performance standpoint, but primarily now just interested in everything the technology as a whole. Just trying to learn as much as I can. Um, I'm a mechanical engineer, and so I don't have a lot of experience with like chemical compatibility and like end of life treatment for fluids. But
I'm coming from mechanical engineering myself, so there's definitely been some learning.
right, right, right.
Yeah. Okay. I think we got another join Philip from Grimfoss. Oh, to introduce myself, because I don't have the label on there. I'm Alex. I work for Enios, which is a single phase fluid company. And before that, I worked for GRC, which is a single phase immersion tank and CDU company. So I'm going to pull up the the white paper. We can take a look at that. Um, we'll have a pretty short meeting since this is going into holiday, but give you a preview for what we'll be working in the coming year. So just sent the link in the chat. One second.
Is that a link to the document?
Uh, should be, but it wasn't.
Okay. Yeah, it's pulling up Zoom.
Yeah. There.
Okay.
It should have comment access at least. So you guys can take a look at this um, right now. With the we're looking at how to get this more quantitative. Say it's very qualitative right now, kind of listing the different options. I think for the section where we focus on first, let's see. Okay, so main review of options over in seven. So you got recycling, destruction, few options. So we're hoping to get numerical comparisons for there.
Mhm.
That's,
Okay. Have you referenced any methodologies from any other industries or organizations?
well, I thought it would be using CO2 equivalent, but you're probably more of an expert in the room here. What do you think?
Yeah, I think yeah, the CO2 equivalents, I think would be the units that we're going to look at for the carbon footprint.
Okay.
Um, and and so let me make sure I'm understanding the what. So we want to have methodology to be able to calculate that carbon footprint
Gate
from
to grave.
gate to grave. Okay,
Hmm.
yeah.
Or primarily, end of life use to
Uh-huh. Okay. So are there, do you have any other methodologies that you've referenced to this point that you're aware of? So like, I'm asking like the API, the American Petroleum Industry, I think, they have their own methodology. Um, I mean, that's for like base oils and things like that, but we could take that methodology and translate it to these types of fluids.
Okay,
Mhm.
that's a good idea.
So I can get those documents and we can that maybe give us a starting place.
Yeah, that sounds helpful.
Okay.
See if there's a guide to get started on there,
Okay.
and then probably tackle each section of the life cycle.
Hmm. Yeah. I'll need to pull them up and look at them.
Okay. Is there see
But
if we can find a
for
guide to those?
what's that?
Yeah, see if we can find a guide to those.
Okay.
What were you saying?
I didn't know if we wanted, if that is an action item for me for another meeting, or do you want me to try to do that now? Or
Oh, I don't want to give you homework over
oh
Christmas.
yeah, yeah. I've
Yeah,
still got a few days left. I gotta keep my mind occupied.
for sure. Yeah, this meeting is mostly just a recap for.
Okay.
We'll
Okay.
dive more into it next year, but
Okay. Okay.
certainly if you have some resources that you want to comment in, that would be
Yes.
some good reading for where to start. That would be extremely helpful.
Okay. I'll let me look for those and I can post them in the
Okay.
chat if I can find them.
Yeah, you should have comment access. Do you want to check on the
Oh, okay. Okay.
that'd be easiest there.
Let's see.
Yeah, a lot of the recycling is I know there's some regulations on halogen and toxic parts of recycling, but I don't think the immersion application would get into that toxicity.
Mhm.
Is everyone US based or any others here?
Yeah, we're US based, out of Mississippi, the Jackson area, but we have sales offices globally.
US based. We have an office in Endicott, New York, but I'm in Mesa, Arizona.
Okay. Yeah, I'm in Austin, Texas. Uh, Office is up in Chicago. Okay. Yeah, so we know what our expertise is. I imagine we'll make it pretty US focused, but that's what we know.
All right.
And sounds like we'll need to get some two-phase folks in here because that is a pretty different process, I imagine, compared to hydrocarbon based. Jensen, you're saying you're a field engineer for a few US around?
Yeah, field applications engineer for Amphenol Industrial.
You seeing much these immersion deployments or
Um, so we're relatively new to the liquid cooling sphere, and so we've been working primarily with the conventional liquid cooling and trying to investigate immersion in the two phase because that seems with the density and the power densities and cooling that seems to be where the industry's headed. So we're not overly involved with the immersion in two phase yet, but we're trying to see where we can help out with that.
okay. Yeah, usually the return of components that have been immersed might be a little different. I know there's another work stream that does cleaning of IT return. I imagine that's might be something your company is looking at as, when parts fail, if you do anything different on them once they've been
Right.
immersed. Yeah, so there's quite a few groups on that. I know you guys started testing connectors and components in the immersion fluid.
Yep. Agreed. 100%.
Okay. Compatibility. And, we've got the OCP meeting coming up for EMEA. Is that something y'all are attending, or did you come to the last event, the global summit in California?
No, I
Yeah, I made
wasn't able to make it to the global summit. I wanted to, but I had a conflict.
Okay, always a lot of good talks there,
mhm.
but they do record it because honestly, when I'm there, I don't have time to catch them all either.
Hmm.
Okay.
So I'm
Yeah.
going to share this document. This is from the what is it called? The UEIL, which is the Union of European Lubricants Industry, and it can give a framework to work off of if we want to use that.
Okay.
Like I said, even though it's for lubricants, it'll kind of give us an idea of what to look for, what to include.
Well, most single phase immersion fluids are essentially lubricants.
Yeah, right.
Okay.
And this is how the European Union, but one of my colleagues worked closely on developing this methodology. And, if we need help, I can certainly get her involved as well.
Okay. Some checking that chat link here.
And then they also have a calculator available where you can, I haven't personally used it. I've looked at it, but you can go in and input your information, your data, and it'll kind of calculate that footprint for you.
Oh, is that, I guess, which segment of footprint?
Um, let's see. I'm not sure what the boundaries are. Let's,
Taking a look
I
at that
think,
thing
yeah, I
just
think
now.
it's just cradle to outbound gate.
Okay. Yeah, that makes sense. That's, mostly the scope of interest for them. Okay, well, I'll take a look at those calculators, but yeah, I'd say the main intent we're trying to address is what should people do with their fluid end of
Okay.
life? And that's kind of up to us to how to answer that question.
Okay.
So part of it's carbon footprint. If we can think of other metrics or considerations, that's certainly relevant.
Yeah.
Uh, Besides the carbon footprint, or the other metrics, certainly cost is one. If there's
Yeah, for sure.
Yeah, so when you're doing the life cycle analysis, was there other metrics besides CO2 equivalent for the output of the analysis?
Yes, we had more like emissions kind of metrics. So the acidification potential, which is I think SO4 equivalents, eutrophication, which was phosphate maybe. Um, what else? Energy demand, um, primary energy demand, PEDR, um, and then blue water consumption, particle matter. But I think a lot of those are emissions driven, like for the process of um, the refining process itself, manufacturing process.
Okay.
So I don't know that that would be applicable for, for end of life.
Well, it'd be dialing into what the fluid would go through.
Mm-hmm.
I know some of the base oils can are just incinerated as fuel oil, so that
True.
would be
Yeah.
some some emissions there as
Mm-hmm.
combustion. Then we'd have to weight how much the I guess the calorie value of the heat, whether something else was used to burn it.
Mm-hmm.
Yeah, and then the recycling, if they can filter it, taking out additives, that's pretty neutral.
Yeah, you may have to look at the, I don't know if you want to go that far, but like the filtration media, how it's, if it's got some kind of contaminants in it, how do you dispose of those? But like I said, I don't know if you want to go that far, consider that much. But I guess if it's like regenerated through a chemical process, then you can look at those emissions um, metrics.
Okay. Yeah, brainstorm right now. Yeah, how do we I'm sure there's no limit to how much you could calculate. Yeah, I guess what are you guys' thoughts on how to initially tackle the question of numerically guiding people what the right solution would be?
Yeah, that's a good question. So is the goal maybe to do a calculation for each one and say, okay, this is the lowest uh, environmental impact or whatever cost, um, and have like a matrix like that? Do you want, or are you just providing kind of a framework to think about and have each user calculate their own and come to that conclusion?
Well, I imagine there's some variability on per use, so it
Mm-hmm.
might be hard to make a general answer.
Okay.
Yeah, I think I'm sure a lot of the missions are, if you got to truck it from the East Coast to the West Coast to a specific processing, maybe that no longer makes sense.
Mm-hmm.
So, Matrix sounds great. Unsure if that's something that's feasible to make a general rule,
Mm-hmm.
but some guidelines on how one could calculate, or at least
Mm-hmm.
you figure out the pieces you can and then into the data you couldn't, or that's case by case.
Yeah.
So I suppose the individual processes, whether that's start with incineration, start with recycling, and then fill in transport, that might be the variable there.
Yeah.
Yeah, what do you think? What would be the most useful for users of cooling systems?
Um, to have a, generalized number, I guess, would be the easiest. So you could just look at it and say, okay, this is the least environmental impact. This one, has a little more cost, but I'm more concerned about the environmental impact, or I'm not concerned about the environmental impact, and this one's the lowest cost. And because it's difficult to do the calculations, and so not everybody is going to be able to or want to do the calculations. And I think just having a reference just to go to and be able to look at the matrix and make the decision based on, I guess, a generalized set of data is probably what I would prefer to do.
Yeah, I think you nailed there. A guy who
Yeah,
manages a server's data center probably does not want to read all these how to use these calculators.
exactly. And like I
Yeah.
said, I haven't even used this calculator, and I'm, our LCA person. So for the, the lubricants um, methodology. So yeah, I
Okay.
think just having the guidelines, like maybe that's the whole idea, is that this just is a guideline. So yeah, let's just have a quick reference matrix kind of thing with the different scenarios.
Okay. I like it. Good. I think we got some future looking ideas on how to get this tackled.
Okay.
Yeah.
Okay. So for the matrix, I know you were asking like what other um, metrics we could look at. So, environmental impact, CO2 emissions, um, cost, toxicity. Although you said most of these probably won't have any toxicity.
I wouldn't think so, no.
Okay. Unless I noticed like the acid filtration, maybe pulling up the document. And I don't know details about acid scrubbing, um, like what acid that is. Um,
Let me pull that up. Oh, a lot of that's the two phase, and my expertise is in safety. So my other co-lead is part of the two phase section, so I'm gonna leave that one to him.
okay.
But yeah, certainly in the two phase, the equivalent work will need to be done.
Yeah. So just thinking about like the acid scrubbing, what's done with that acid after it's used, the distillation, it's got contaminants, blah, blah, blah. Um, so maybe toxicity would be one to include.
Yeah, that's yeah.
Mhm.
Well, yeah, so I guess the next meeting I'll read through these methods you listed, get a little smarter on there, can start cracking on that. For the immediate future, we're going to be sending this white paper out for review to the wider audience. If you haven't read it, please go through, and if there's something wrong or misleading, concerning, definitely mark it. Um, the more eyes on this, the better. So the idea is getting this, these published as a first draft. So right now, this has been just on an internal team, but it's pretty well there as a general guide. So any comments you have on that, much appreciated.
All right.
Yeah. Okay.
All right.
And then we'll meet coming in the new year. We'll start trying to tackle these things. But yeah, keep an eye out for, well, of course, comment on this much as you want. There probably will be some emails for getting it out to wider review, but yeah, go ahead and start on it.
Okay.
Yeah. Well, we can close up, get a little time back. Appreciate y'all's help and joining the group, and looking forward to making some progress.
Good. Well, thank you.
Thank you.
I feel like I actually contributed to this group. Some of the other ones I just sit in and listen. So it's good to be able to contribute.
Certainly, and that's actually one of the reasons I joined this one is because some of the fluid ones have 60, 100 people there, and it's hard to make a contribution. So this group certainly will take it.
Cool. All right. Well, nice
Cool.
to meet both of you, and look forward to working with you on this.
Likewise. All right. Have a good one.
You too. Bye.
Bye.